name's Dave Franzen, and I'm an extension soil specialist with NDSU out of Fargo. My emphasis area is soil fertility, as you know, and Abby Wick, my counterpart, soil specialist, her emphasis area is soil health, and we overlap from time to time and work together on certain projects. But I'm going to concentrate on soil fertility today, and so here we go. So here's an outline of the updates I'm going to cover. The first one is going to be iron deficiency chlorosis, or IDC. The next one is nitrogen, phosphate, potassium, and the last one is sulfur and micronutrients. So if you're in the eastern part of the state, you know exactly what this is, unless you just started farming, when previously you were in Ohio or someplace. So those of you in the western part of the state, and soybeans, of course, are grown all over the state, but particularly in about the east 60 miles of the state, it's pretty remarkable. You go from Buxton north or near Armenia, north of Castleton, and you can see entire quarter sections that are entirely yellow from one border to the other border, east, west, north, south. It's really pretty incredible. So this is not the way they're supposed to look, but this is the way they look in some years. So if you look down on the plant, this is what you're going to see. You're going to see that the monofoliate leaves, cotyledons, are green. And then as soon as the trifoliates come out, if the conditions, the soil conditions are right, then they're the ones that are going to turn yellow. And we call it interveinal chlorosis. You can look closely at that middle plant and you can see that the veins are green. And the interveinal area is yellow, and that's usually what you see. Sometimes the severity is so horrible that even the veins are yellow, but at least they're the last ones to turn yellow. So the only cause, and this is really the only, well, it's the only cause. The only cause of this condition is the presence of carbonates in the soil. So if you're doing a zone sampling of the fields, which I highly recommend, for both acid soils and to figure out where the carbonates are. If you zone sample a field and you have a zone that has a pH of 7 or above, then you have carbonates in the soil. And there are regional soil testing labs that can actually test for the carbonates, so to give you an idea of how at risk certain areas in the field or certain fields are. And so I encourage you to take advantage of that if you see areas of the field that have pHs over 7. The greater the carbonate, the greater the risk of IDC. That's the cause. That's the only cause. So the reason this is the cause is that soybeans originated from eastern China, where the soils are slightly acid to acid. And so they never evolved with any kind of consideration of any carbonates in the soil or any strategy to overwhelm the soil ability to prevent the iron from entering the plant. All of our Middle Eastern crops, so the lentils, the field peas, the chickpeas, they have that built in, but soybeans don't because of where they came from. So what happens is a strategy for soybeans to get iron is to take that really insoluble iron that's in our soils, the oxidized stuff, and to reduce it to iron that's very, very soluble. And so the soybean is spitting out this protein all the time, but it only acts when the soil is a little bit acid. It doesn't work. So the bicarbonate neutralizes the acidity around the plant work and renders that protein inactive. So that's the cause. So we see this all the way across the state, and the more water there is, the more carbonate is dissolved. It's not a particular soluble. It's not in our bucket of soluble salts that we talk about when we talk about EC or soluble salts. It's not in there, but it is soluble to some degree. And the wetter the soil is, the more bicarbonate there is. That's why once you get about 60, 80 miles west of the Red River, that the occurrence of IDC is usually only in certain parts of the field that tend to be a little bit wetter, or maybe after a particularly long-term wet event in the west. But it's not the huge deal that it is over here on the east. Also in the east, we have other things that interact with it. Once you have the moist soil, there are additional stresses always cause an increase in the appearance of IDC and the severity of it. So the wet soils are important. When you have a cooler spring, so you planted early, you have a cooler spring, wet soils. We've also seen it with certain herbicide stresses, even Roundup. You don't think of it as a stress, but the soybean has to fight it to some degree. Our biggest stress that doesn't occur in any of the I states where some of our company generated IDC tolerance numbers come from is soluble salts. We have soluble salts. The I states have no soluble salts. It's a huge difference between growing soybeans here and growing soybeans up there. This is North Dakota generated relative soybean yield on the left compared with the soil 1-to-1 EC, the stuff that's run in the lab routinely on the bottom. And when we get to maybe an EC of 2, we've lopped off, I don't know, anywhere from 20 to 25% of our yield, even without IDC considered. So it's a big deal. And then you combine those IDC stresses that Hans showed us with combined with the salt, and it can be tremendously horrible. So we see soybeans that are yellow all season never really do green up. It's not all that uncommon to see areas and sometimes entire fields like this, and it's unusual for those yields to be above 10 bushels an acre. So have your insurance agent on speed dial. So these are the strategies for IDC reduction. I know our acres of soybean is totally increasing, and I get it. I understand the low costs, and I'll talk about that. Also, that has a low fertility requirement, and you can easily spend $100 an acre on fertilizer for corn or canola, but you know, you could probably in many soils you can get by with nothing for soybeans. So I get it, but you have to select your fields correctly. You can't pick a field that will barely grow barley and then you're going to stick soybean in it. It's just not going to work. So variety selection is extremely important, that Hans talked about, and we're extremely fortunate in this state that first Jay Goose and now Hans has worked with our soybean breeder to do that tolerance. It's a great asset for you. So believe that IDC number way more than you will the company IDC numbers that are, I don't know, they used to be in those little seed books. I know that now you just get them online. So I wouldn't believe those at all. I'd believe the NDSU ones because they're grown in soils that are like yours. They have salts, they have the high carbonates. Then the right iron fertilizer, and I'll talk about this. The one that's been the most tested is the ortho EDDHA chelate. Goes by several names. You can also use a companion crop at planting. That cover crop that Greg talked about might be one of the options. The other is to put a cover crop in when you plant the soybeans. And then I put this in, but it's with our weed problem in the state, it's really not much of an option. If for some reason, by some miracle, you have your weeds all controlled, you could go to a little bit wider row, and that'll help you out. But again, you're going to give up some yield when you do that. All right, so this is ortho EDDHA. Where's my little laser pointer? Okay, so this is its structure. It has 1, 2, 3, 4, 5, 6 arms that are holding the iron tightly. And so this is its isomer that's in all the manufactured products to some degree. Some have relatively small amounts of this, and others have most of the iron EDDHA that's in the product is this, because this is cheaper to make than this. So this only has 1, 2, 3, 4, 5 arms on it. So both of these give up their iron at the point of where the soybean is growing. But when the para, this is called para, orthopara, when this is done, then it's done. Once it gives up the iron, it's just done. The iron can't hit it again. It can't be swimming out in the solution someplace, run up against an iron and hold it until it reaches a soybean root again. But this one can. It can go back and has to some reach back capability, and so it can grab an iron from solution and redo it and do the gift that keeps on giving. So this is a study that Jay Goose did before he retired, and it has a product that has only 1.5% ortho in it, and he's put it on at these rates. He gets a little bit of response, but it's not too exciting. Then he uses a product that's 5.5% ortho, and all of a sudden you get excitement. You know, these are the same rates as this, but the ortho is the thing that really makes the system work. You know, the ortho para doesn't. In our law, it says that, you know, you have to kind of put your chelate on the label, but nobody has the ability, apparently, in order to figure out what's ortho and what's ortho para. So don't count on reading that anytime soon on any kind of a label. You just have to kind of go with the products that have been around for a while and have a good track record. And if you want to test those on the farm, replicated strips, yield monitored, or you can visually take a look and see if they're doing anything. All right, so when I'm talking about a companion crop of oats, that's what I'm talking about. So it could be oats, could be barley. Another thing that increases the amount of IDC in the fields is soil nitrate. It doesn't prevent the iron from getting in the plant, but it has the unfortunate problem of being able to oxidize the iron that's in the intercellular spaces in the plant. And so it renders it as a precipitate, and it doesn't really get used inside the plant. So high iron, and what do I mean by high iron? That would be iron that I think above, say, 80 pounds or so, maybe 100 pounds in the top 2 feet. It's not totally defined, as you can tell by my mumbling around, but the higher the nitrate in the soil, if you have background levels of 40 pounds or so, that doesn't seem to be an issue. But once you get up to maybe 100 pounds or so, then you really start. So this is some work that I did with University of Minnesota, and these are the Minnesota sites that I didn't work with when John Lamb was still working at University of Minnesota. And this is 100 pounds of urea N applied in the spring, no cover crop. This is 100 pounds of urea N applied with a cover crop of oats, about a bushel of oats an acre, worked in the same time that the soybeans are planted. And yeah, there was still a little bit of IDC, but it was way better yields here than there were without the cover crop. So it dries out the soil a little bit, decreasing IDC, takes up some of the nitrate, which decreases IDC. So it's kind of a win-win, and it's not horribly expensive. It's certainly a lot cheaper than taking a 10 or 20 bushel hit on your soybean yield. Greg covered this. I'm not going to cover it to any extent. I'm just going to reemphasize that if you are going into new soybean ground, and there's some of that that'll be planted this year, that you definitely need to inoculate. People have had the best luck with double inoculation in the past, maybe using a granular or maybe using a peat or a liquid product back to back, so the granulars piggyback with something else. It seems to be the most foolproof. Single inoculation, sometimes there can be a boo-boo, an error or something like that, and then your soybeans really suffer because they need nitrogen as much as corn does. It's just that when they have the bacteria, then they don't need the extra nitrogen. If you've had soybean within the last 4 years or so, like Greg said, you really don't need to put it on. If you do decide to do it, then fine. You know, it's not a huge expense, but look at the number of cells per gram of soil or left after that initial year. You know, these are little cells per gram of soil, and then what, 2 million pounds of soil in the top 6 inches? You're talking trillions and trillions. So there's plenty there after 4 years. The other thing is there's no need to fertilize soybean with nitrogen. There's just absolutely no need to fertilize soybean with nitrogen. If you're putting on a phosphorus fertilizer, MAP, for example, it's not going to hurt it to put that on. It's not going to help it to put it on. The nitrogen is just a drain on operating expenses. And if I certainly wouldn't put on urea just because you think it needs some, because it doesn't need some. So as Greg said a few years ago, we met in Carrington. All the researchers that I could think of, and I forgot Shana Forrester at Minot. Again, public apology for that. But but I did show her a slide just lately from her, so I know I haven't forgotten her altogether. But we sat around and shared the data that we'd gathered within the last decade or so, and we decided as a group that lowering the critical value of our soil test or Olsen soil test to 7 ppm would be prudent. And so if you're growing soybeans this year and you have a soil test of 7 ppm, 6 ppm, then application of phosphate would be a good idea. But if it's greater than that, then you really don't need it. And so back to the question about whether you should put your phosphate on for corn and then not worry about the soybean. And as Greg said, if you're one of those rare corn farmers that has their soil test greater than, say, 12 ppm, and then you don't need the phosphate at all, do you? And so the question is moot. So, but if you're growing corn and the P test is 3 ppm, it'll be interesting to see what Greg sees on that low testing soil. I think that even if you put some extra P on that low testing soil, the soil test still isn't going to be 7 ppm when you plant the soybeans. And so maybe putting some on would be a good idea if the soil test is still less than 7 ppm, but we'll see. Broadcast or banned seed separated phosphate is overall best. Seed placed phosphorus doesn't increase yield in most trials and can decrease yield, especially if the soil becomes dry after seeding. So we don't want to see the P placed with the seed. So these are our phosphorus rates right now. We have a proposal up against the Soybean Council right now to take another look at that statewide and see if those rates are appropriate or if they're too strong or if they need to be up some. But we're still working on that. We don't know everything about soil fertility, no matter what the books say. So Greg and company did this work at Carrington here a number of years ago, and this is fertilizer with the seed with soybean. This is a 2x2 placement, so this is separated. 4 gallon of 1034, right, Greg? I think that's right. And no difference in yield, no difference in stand. Not a big surprise. When they start putting that in furrow, that 4 gallon, it's not a really high rate, but they're reducing the stand by what, a third, and they reduce their yield by 25%. And then higher rates, of course, decrease the yield further, or decrease the stand further. So don't do this. If you just don't want to do this. There's no reason to do this. So our potash recommendations are based on clay type. In the charts in our soybean circular, you'll see that / thing going on, the 90/90 60-60. What's that? So what that is what your smectite illite ratio is. The number on the left is if you have a lot of smectites in your system that hold on to potassium during dry periods, and the figure on the right is if illites are dominant. And no, I said that wrong. I was looking at the wrong thing. So the numbers on the left are the illitic soils, the ones that don't hold on to the phosphorus or the potash during real drought conditions, and the numbers on the right are for the smectitic soils that hold on to it. So the numbers are higher. They have to be higher because the smectite holds on to it during periods of drought, and we recommend up to 200 ppm. And these are, anyway, the critical values are pretty similar to what we have on corn. So they're based on clay chemistry. This our circular has a map that can show as a guide. Here's the guide. Here's the areas. People would think that maybe most of the areas in the eastern part of the state would be the areas that are really, really high on smectites. That's not absolutely true. We have a large area West River. We have a large area up here. There's soybeans grown in that area, I know. And so those areas have to be watchful when the K-test approaches 200 ppm. All right, so this is an easy one. In-season foliar sprays for NP and K almost never effective at paying back a person for doing it. There were Chris Augustine, when he was my PhD student, he had 2 treatments in north central, northwest North Dakota, 6 site years, no effect on yield at 2 different timings. Hans Condell was in a regional study where, I don't know, there are, huge number of sites all across the country that grew soybeans, and only a couple of them really showed any kind of improvement with a foliar application of fertilizer. And their bottom line statement was that farmers should look for something else in order to increase the yield, but this was not the answer. So how about sulfur? So sulfur is a big deal with a lot of our crops, canola, absolutely, but also our grain crops, our grassy crops, the corn, any of the small grains. Those are particularly susceptible to sulfur deficiency. We have some water now coming into the winter. We probably are going to have more water. The Farmer's Almanac says that this winter is going to be glacial. So far we're on track with that. So we're going to have snow melt, maybe some rainfall in the springtime. We're going to have leaching of sulfate. And so we're likely to see that again. So we should be worried about soybean. I don't see the yield response of soybeans, sunflower, any of our broadleaf crops. And I'm thinking about them all right now, but I can't think of any where it's really widespread. They seem to be just really good at extracting it from the soil. So it's possible. It's possible, especially on sandy soils and that are a little bit higher on the landscape. Sandy, I mean loamy sands and some of the irrigated sands in places. Maybe not so much the sandy loams with organic matter of 3% or so, and maybe not in the no-till soils, which are a little bit more immune from leaching and than some of the others. But the other reason I'm not too excited about it is that soybean is an August crop, and so you can beat it up early in the season and rescue it, and it's going to be just perfectly fine. And so, if I was you, I would just kind of wait and see. And if I had areas of the field and I did tissues from green areas of the field and tissues from not green areas of the field, then and sulfur was a culprit, then I'd apply some then, but I wouldn't worry about it until then. And we don't find any need for micronutrient supplements in North Dakota except for the iron I talked about. So this is the list. This is the recipe, I guess, in terms of fertilizer and amendments. And no nitrogen is required. Inoculation only when years are separated widely or the first year ever. Your critical value of P is 7 ppm. No fertilizer with the seed except maybe the iron. Potassium is related to clay chemistry. Manage the IDC with a multi-prong approach. Monitor soil pH so it doesn't drop below 5.7, and then sample it in the zone. And then sulfur is not an issue for most people, I don't think. So that's my presentation. I'm sticking to it.